So this is Module 1, Topic 1, Lesson 1, Part 3. So we are going to start on the page that says Activity 1.4, and it is page 20 at the bottom. So on page 20, 1.4, it talks about Gaussian elimination. It's like cow with the letter G, Gaussian elimination. So I'm actually going to show you a different way to do this. Now, one thing we do need to fix in our notes is that this example, this right here should be a number 4. And so because they take up so much space doing everything else here, there's not room. So you will need an additional piece of paper right here. And I'm going to show you how to go through this problem and solve it. Okay, so anytime you see Gaussian elimination, this is the method that you're going to use to solve it. And it is the exact same method we did in the previous part of the video. So it's just showing you again. So here we go. We have 3 equations, we have 3 unknowns. What we want to do is we want to create 2 new equations. So we need to decide what variable do we want to cancel out and what do we want to be our main equation. So this is going to be our main equation, and I'm going to pick to cancel out the x variable in each equation. So what we're going to do is we're going to take these 2 equations and we're going to do the elimination method. Okay, and so we'll do that first. So we have 2x plus 2y plus 3z equal to 3. Then we have x plus 3y plus 2z equal to 5. We want to cancel out the x variables. So what we're going to do is we're going to multiply this equation by a -2, so that way the x can be canceled out with that positive 2x. This first equation is going to stay the same, 2x plus 2y plus 3z. And the second equation, we have to distribute that -2. So we get a -2x, we get a -6x, or 6y, and we get a -4z, and it's going to be equal to a -10. And I just realized I didn't finish writing this. On top, it equals 3. So now what we're going to do is we're going to add these 2 equations together. So when we do this, 2x plus -2x cancels out, which is what we want. 2y minus 6y is a -4y. 3z minus 4z is a -z. And 3 plus a -10 is a -7. So this is one of our new equations, and I'm going to highlight it just so it stands out. We're going to need it in just a second. Now we're going to do the same process again, but with that middle equation and the last equation. So that middle equation gets used twice. One equation will always get used twice. So I'm going to rewrite them. So we have x plus 3y plus 2z equal to 5. We have 3x plus y plus z equal to 4. This time, we still want to cancel out the x variable. So you have to cancel out the same variable when you do this step. So it has to be x. So that means that to cancel out the x's here, we need to multiply this first equation by a -3. So when we do that, we get -3x minus 9y minus 6z equal to a -15. That bottom equation does not need to change. So we have 3x plus y plus z equal to 4. We're going to add these 2 equations together. So we have -3x plus 3x cancels out. -9y plus 1y is a -8y. Negative 6z plus z is a negative 5z. And negative 15 plus 4 is a negative 11. So we have our second new equation. Okay, so that's step one. One equation you are using for both parts, and you're canceling out the same variable in both parts. Now step number two. What we want to do is we want to take these two new equations and we want to do the elimination method again, canceling out a different variable. So that means we're going to take negative 4y minus z equals negative 7. And we're going to take negative 8y minus 5z equals negative 11. Okay, so from here, you get to decide, do you want to cancel out the y variables? Do you want to cancel out the z variables? It doesn't matter either way, you're going to need to multiply one equation by something, okay? So in this case, I'm going to say let's cancel out the z variables, okay? So these we want to cancel out. We need them to be the same number but different signs. So that means this second equation is going to be multiplied by negative 5. Okay, so the second equation is going to change. So we get a positive 20y, a positive 5z, equal to a positive 35. The bottom equation is going to stay the same. It's not going to change. So negative 8y minus 5z equals negative 11. And now we're going to add these two together. And so 20y plus a negative 8y is a 12y. 5z plus a negative z cancels out. And we have 35 minus 11, which is 24. And now we have an equation that just has one variable. So what we can do is we can solve for that one variable by dividing by 12. And that gives us our first part of our solution where y is equal to 2. So we have our first part of our solution. Now that we've done that, we can use this and plug it back into one of our previous equations to solve for another variable. So that means that now that we've done all this, we're working the opposite way. So now we're going to take this and plug it in for the y in this equation or plug it in for the y in this equation. Either way doesn't matter. Now, because this one is a negative 5z, I'm going to choose to go to this one because it's just a negative 1z and it's just a little bit less work. So what I'm going to do is I'm going to write that equation down. And we're going to plug in 2 for y. So I have a negative 4 times 2 minus z equal to a negative 7. So negative 4 times 2 is a negative 8 minus z equals a negative 7. So I'm going to do something that most of us may like, but if you want to try it a different way, you should get the same answer. I am going to actually add z to both sides. And then I'm going to add 7 to both sides. So when we do this, negative 8 plus 7 is a negative 1. Negative z plus z cancels out. Negative 7 plus 7 cancels out. And then I'm just left with equals z. So now we just found our second solution to our equation. So now we just need to find our third solution to the equation. So again, we solved here. We went back a step to plug in. Now that we have two variables, we're going to go back to one of the original equations to plug in. You can pick either equation to solve for, because in this case we're solving for x, I'm going to pick the equation that has x by itself. So I'm going to write that down. We have x plus 3y plus 2z equal to 5. So we plug in our variables. We have x plus 3 times 2 plus 2 times negative 1 is equal to 5. And now we solve. So that would give me x plus 6 minus 2 equals 5. We get x plus 4 equals 1. Oh, not equals 1, equals 5. Then we can subtract 4 from both sides, and that gives us x equals 1. And there's our third solution. And so the very last thing we need to remember to do is to write our solution as an ordered triple. That means that we have our x, our y, our z written like that. Okay, so again, this right here was step number 1. Take two equations, add them, cancel out a variable. Step number 2, take 2 equations, cancel out the same variable, so we get 2 new equations. Step number 3, add the 2 new equations to solve for 1 variable, and then it's a lot of plugging back in. So this was step 4, step 5, and step number 6 was writing your final answer. Okay, so that allows us to skip this page as well. We're going to skip a lot of pages, skip this page, keep on skipping. We're going to end up skipping this as well. I just don't have a line through it. Okay, we're going to keep skipping here. And so now, oh, just kidding. We're not skipping this whole page. We are just skipping number 4, and we are going to do number 5. Okay, so it's a word problem. We're going to write the equations and solve the system. So here we go. Colleen has 12 coins in her pocket. The mix of quarters, nickels, and dimes add up to $2. And she has 3 times as many quarters as nickels. So first thing we need to do is write the system of equations, and we need to make sure that we define our variables. So for this particular problem, let's see. We're talking about quarters, nickels, and dimes. So let's let Q be the number of quarters. Let's let D be the number of dimes. And let's let N be the number of nickels. So we're going to write a system. So first off, how many total coins does Colleen have in her pocket? She has 12 total coins in her pocket. So what that means is she has quarters plus dimes plus nickels equal to 12 total coins. Then it says the mix of the coins adds up to be $2. So this is talking about the amount. So how much is a quarter worth? It's 25 cents, so 0.25 quarters. A dime is 10 cents. And a nickel is 5 cents. And it's equal to a total of $2. Then the last equation. she has 3 times as many quarters as nickels. So she has 3 times the amount of quarters as nickels. So my quarters are equal to 3 times the nickels. And so from here, all we need to do is we need to solve. So this is similar to one of the other problems we did in a previous part. So because we have one equation already solved for, or one variable already solved for, we are just going to use the substitution method where we plug it in for that q and that q. So what this looks like is we have 3n plus d plus n equals 12. Combine our like terms. We have 4n plus d equals 12. From here, we can plug it into the other equation. So we have 0.25 times 3n plus 0.1d plus 0.05n equal to 2. So 0.25 times 3 is 0.75. Then when I combine my like terms, 75 cents plus 5 cents, that is 80 cents. Okay. And now we have two new equations. This is a new equation. This is a new equation. What we can do is we can either do elimination or we can do substitution, whichever method you prefer. So for this one, I'll go ahead and do substitution because I see that I do have a variable by itself. Okay, so here we go. I want to solve for d. That means I need to move the 4n over. And so that gives us d is equal to a negative, actually I'm going to start with 12, 12 minus 4n. And so now I can take that and plug it in the equation next to it. So 0.8n plus 0.1 times 12 minus 4n equal to 2. Okay, and I did forget to color coordinate it, so let me go ahead and color coordinate so I can show, oops, we're plugging in something different. So I'll make that, we plug in red. Okay, so there we go. Now we can go ahead and start solving. So we have 0.8n plus 0.1 times 12. That gives us a 1.2. Then we have 0.1 times negative 4. That gives us a negative 0.4n equal to 2. Combine like terms, 0.8n and minus 0.4n, that is 0.4n. I'm also going to subtract 1.2 from both sides. So 2 minus 1.2 is equal to 0.8. Okay, from here, divide by 0.4 on both sides. And 0.8 divided by 0.4 is 2. So we solved for n. Okay, now we need to solve for Q and for D. So if you notice, we have an equation where D is already solved for, and we have an equation where Q is already solved for. So all we have to do is plug in 2 into this equation because there's an n, and a 2 into that equation because there's an n, and we solve for D and for Q. So if we do that, we have D is equal to 12 minus 4 times 2. D is equal to 12 minus 8. And so D is equal to 4. Then I can plug it into my Q equation. Q equals 3n. So Q is equal to 3 times 2. That means Q is equal to 6. So, what does this mean in the context of this problem? There are 4 dimes, 2 nickels, and 6 quarters. And that's what this means in the context of this problem. Now, if you were to get a negative answer, okay, if you were to get a negative answer, that's not going to make sense because you can't have a negative amount of coins. Okay, so keeping that in mind as we go through this. Okay, so that is the end of the lesson. You do have some homework questions here. Okay, so some homework questions here. And this is a list. Oh, no. Here is some additional homework problems. So you'll need to write these down. All of this information can be found in Google Classroom under Module 1, Topic 1, Lesson 1. It tells you where all your homework problems are, and it also has these 2 additional problems listed, as well as other videos for this topic. So if you have any questions, please make sure you ask me so I can help you out.